So good morning friends, today we are going to be studying about relation and function, which is a first chapter of class 12 mathematics books. It's quite a scoring chapter, and it consists of majorly three parts. First is equivalence relation. Equivalence relations questions just come to prove equivalence relations. So we have to prove three things in equivalence relation. First is reflexive, then symmetric, then transitive. So first we are seeing what is reflexive. Reflexive means same to same or two things which are idle to each other. So if a comma b is contained in R, then a comma a should also be contained in R. That's the condition for reflexive. Secondly, for symmetric, if a comma b belongs to R, then b comma a should also belong to R. That is the condition for symmetric. And for transitive, a comma b belongs to R and b comma c belongs to R, then a comma c should also belongs to R according to the conditions which belongs to transitive. So further we will be seeing some questions which will surely queries should solve your queries. So thank you and do subscribe my channel. Discussing the questions on equivalence relation. So if z is a set of all integers and r is a relation on z defined as r equals to a comma b belongs to z and a minus b is divisible by 5. So we have to prove that r is an equivalence relation. So we will just start by copying the above r statement here in downwards. So r equals to a comma b belongs to z and a minus b is divisible by 5. So first of all we have to prove reflexive. So as we know that a belongs to z and a minus a is equals to 0. So 0 is divisible by every number, and so a minus a equals to 0. So 0 is divisible by 5. So a comma a will belongs to R for all a belongs to z. So now we will look upon symmetric. Let a comma b belongs to R. So it is given that the condition a minus b is divisible by 5 and a is any constant. So b minus a will be divisible by 5 also. So 5 minus a. So b minus a is also divisible by 5 for all b comma a belongs to a. Therefore it is symmetric. Now we will look upon transitive. Let a comma b belongs to R and b comma c belongs to R, and a minus b and b minus c are divisible by 5. So on adding, the b and b gets cut and 5a plus 5b. So now as we see, 5 is common and it is divisible by 5. Therefore R is transitive and R is reflective, symmetric and transitive. So hence it's proved. And note, if any one of the condition is not true, then it's not an equivalent.